IPv4 private addresses and also NAT. In this video, I'm going to talk about two topics. First, IPv4 private address, and after that, network address translation. You have learned about them in the CCNA class. You know that inside of our company, we are using private IP addressing for preserving the IPv4 addresses. And in private IP addressing, according to the RFC 1918 address allocation for private internets published in 1996, okay, we have three ranges. The first range is in class A 10.0.0.0/8, okay, and actually it means that we are starting at the IP address from the 10.0.0.0 to 10.255.255.255. After that, we have 16 range in the class B 172.16.0.0 to 172.31.255.255, and finally, you know that we have 256 network in the class C 192.168.0.0 to 192.168.255.255. We call this range private IP addresses, and all of other IP address, okay, in class A or class B and class C are calling public IPv4 address. Here we can write here 10.0.0.0/8, and here we can say this is a 172.16.0.0/12, and here we can say this is 192.168, okay, 0.0/ for example 16. And also, you know that we are using private IP addressing for communication only inside of our network, inside of our company. For communication with outside of our company, we need the next feature, NAT, or network address translation, or some versions, some, for example, types of NAT. For example, you know that we have static NAT, we have dynamic NAT, and also we have dynamic overload. We call it PAT, dynamic overload NAT, or a port address translation. Okay, in this video I'm going to use the CCNA video that I have explained all of these topics, IPv4 private addresses, and also static NAT, dynamic NAT, and dynamic overload NAT, because ENSLD needs to, for example, talk about them, but it doesn't explain all of them with more, for example, detail. Only briefly ENSLD talk about these topics, but in the CCNA class I have explained all of them completely. Because of that, here I'm going to show you the CCNA video related to IPv4 private address and these topics about the NAT, and after that, in the next video, again I will give you a little more information about the NAT. Because of that, here about these topics about IPv4 private address and also NAT, we will experience two videos. This is the first video that we are using the CCNA video for understanding the detail of these topics, and after that, in the next video, we will review some of the other features, and also we will experience one scenario related to other type of NAT. We call it dynamic overlapping NAT, okay, for more understanding about the NAT. Because of that, let me to talk about IPv4 private address and also static NAT, dynamic NAT, and dynamic NAT overload. Don't forget, maybe the configuration of these NATs are a little beyond the scope of ENSLD. In ENSLD, we are talking about only the concept, but I want to show you the configuration because it is informative and it can help you to better understanding the concept. Network address translation, or NAT. In this video I am going to talk about the NAT, one of the most important and most useful features in today's networks in the TCP IPv4 network. You know that in the IPv6 part of this class, I have explained why we need the NAT, okay? And also I have explained that the NAT is a short-term solution for IPv4 for example, address exhaustion. But now, before talking about the NAT, let me to review some of the, for example, historical reason about the IPv4 address exhaustion. After that, we can start to talk about the NAT, the concept of the NAT, the configuration of the NAT, and also the verification of the NAT. Okay, let me to start. You know that we are using internet. In internet, we have many devices. For example, computers, laptops, servers, and in today's all of the home appliance, all of the car appliance can connect to the internet with IoT or Internet of Things. You know that each device can connect to the internet. Because of that, each device needs to have for example, one IP address, at least one IP address. And you know that the IPv4 address has only 32 bits. And with 32 bits, you can create maximum 4.3 billion IP address. And this is not enough for all of the devices in the network. Because of that, we need another type of IP. Yes, I know that you have learned about the next generation IP, the IPv6 in this class, but you know that the implementation of the IPv6 cannot occur over a night. We need time for example, creating the rules, creating the protocols and other functions. After that, we can implement the IPv6. Because of that, we need some short-term solutions to, for example, saving the time for the IPv6, and finally IPv6 can be for example, deploying all over the world in all operating systems, in all, for example, networks, and also the administrators of the network can learn about the IPv6 and, for example, some other things. Because of that, the IPv6 is the long-term solution, you know it. And we are using IPv6 for the first reason, for example, it's larger address space in compared with the IPv4 address. You know that in IPv4 we have 32 bit, but in IPv6 we have 128 bits, and this means that we have 10 to the power of more than 10 to the power of 38 in the IPv6 IP address. Okay, and because of that, this is a long-term solution, and we have learned about it in the CCNA, and also we will learn about the IPv6 more than this in the higher courses. But now I am going to talk about the short-term solution. Okay, in this video we will talk about the short-term solution for the shortage of the IPv4 address. Okay, what is the short-term solution? A short-term solution is a solution that can help us to saving the time for implementing the long-term solutions. For example, one of the short-term solutions is NAT. Another short-term solution is the private IP addressing. Okay, and after that, maybe the next, for example, short-term solution is the CIDR, or classless inter-domain routing. Okay, I know that in the CIDR, or classless inter-domain routing, we have some features related to routing, not to the, for example, only the addressing. But let me to review first these solutions, the private IP addressing and also CIDR. After that, we can start to talk about the NAT, and after that we can configure the NAT, and finally we will learn about this short-term solution. You know that in the first days of the internet, okay, we had many computers, that these computers should connect to the internet. And as you can see, each system needs one unique IP address. In the first days, okay, we had some organization such as the INA, Internet Assigned Number Authority. Okay, INA should assign each system one unique IP address, or one classful IP address for each company. Okay, you know that in the first days of the networks, we used the classful networks, class A, B, or C. And this means that, for example, each company in the first days could take for example, one range IP address, and after that, from that range, the company, for example, could give IP address, could assign IP address to the systems. For example, assume that here we have one company, this is our company, and in our company we are using the range of the 1000/8